So, welcome to everybody, and it is a pleasure to have you to this webinar. And this webinar dealing with the use of biocontrol agent to control seedborne pathogens. We know how much important are seedborne pathogens, and the use of biocontrol agent is highly desirable. But there are a lot of issues that are connected with the use of biocontrol agent. We will discuss today with you all, and all participants are welcome to be part of this discussion, taking some questions to the speakers into the chat. And this webinar is organized by the ISPP Seed Pathology Committee, and it is done together to the ESF, the ISTA, and the Italian Association for Plant Protection. And a very excellent contribution was provided by International Seed Federation. And here we have Rosa Souza Richards, that is the Seed Health Manager. Rose, you are welcome to take a welcome address.
Thank you so much, Gianfranco, and good afternoon. Good afternoon, everyone, and welcome to today's webinar, which is a very, very interesting one for all of us who are here, very much so for the seed sector. Biocontrol agents to manage seedborne pathogens. I think that we're going to have a very good discussion, Gianfranco, by the end of it, after all the presentations have been coming. So as Gianfranco has already said, my name is Rosa Richards. I am the Phytosanitary Affairs Manager at the International Seed Federation and also a member of the Committee of the International Society for Plant Pathology. It is an honor to be here today with you guys alongside Gianfranco and also with Ruth Bannon, which is the chair of the East Seed Health Committee. For the ISF, this is a very important webinar because it aligns with our mission to promote the harmonization of seed health measures globally. By exploring the potential of biocontrol agents, we can offer sustainable, science-based solutions that safeguard seed movement across boards while supporting biodiversity and agriculture productivity. In an industry where seed health is directly linked to food security, understanding and applying innovative biocontrol techniques is key to maintaining resilient agricultural systems. Biological control is increasingly recognized as a vital tool in modern agriculture, offering environmentally sustainable solutions for managing seedborne pathogens. And today's webinar is designed to shed the light on the innovative methods and advancements in this field, exploring how biocontrol agents can ensure seed health while protecting the seed microbiome and promoting agricultural sustainability. These are goals that resonates with the ISF vision for robust and sustainable global seed sector. We are privileged to have some of the leading voices in the industry joining us today to share the expertise. Our esteemed speakers include Carola Peters from Incotec, Lisbeth van Hagen from Biozaden, Julia Emanuela de Souza from Nampi Bio, and Rob Gaffney from BASF. We hope that today's discussions will not only broaden your knowledge, but also inspire action and developing practices that benefit seed health while contributing to sustainable agricultural development. This is a key priority for ISF and always members. So I'll hand it back to you, Gianfranco, and then you can introduce all the next speakers.
Thank you, Rose, for the important contribution provided to the very good introduction. I told that the people that are listening to the webinar can pose the question to the chat. Please do not ask if the speaker will share the PDF to presentation, because they kindly already told yes. So let's go on with introduction of Ruud Barnoorn for ISTA.
Thank you, Gianfranco. Welcome everybody. Have a good day to you all. I really am looking forward to this very nice presentation and webinar, actually, as a follow-up from last year's webinar, where two speakers talked more about the chemicals involved in the applied to seeds for to attack seedborne pathogens present on seeds. In this case, as the world moves further and the Western world is moving away from more use of chemicals, of course, the biological agents come into view. And that's not coming in for just a couple of years now, but it's already there for about 20 years that we're working on biological agents worldwide. From ISTA's perspective, there are quite some interesting things about the regulations in there, because, well, ISTA strives for the uniformity in seed quality evaluation worldwide and supports international trade on this perspective. Where countries, different countries put up regulations themselves by the day now, it becomes harder and harder to get these new biological agents allowed into the different countries. And I think that's a step that ISTA could work together with ISF, ISPP, and other organizations to help in harmonize regulations worldwide, and all for a good food supply for everybody in the world, right? Back to you, Gianfranco, and everyone have a good time in listening to this webinar.
Thank you, Ruud, and thanks for the contribution that ISTA is posing in a better knowledge of the whole system. And let's start the introductory phase with Carola Peters. Carola, the floor is yours.
Thank you. Let me first share the screen. Can you see it in presentation mode now?
Yeah, perfect.
Okay, good. Okay, so good morning or good afternoon. Thank you for giving me the opportunity to speak in today's webinar. My name is Carola Peters and I'm a researcher at the seed enhancement company Incotech. And today my presentation is titled Green Warriors in Seed Treatment. And we'll be looking at why we need green warriors or biocontrol agents, how we can use them against seedborne pathogens, what different types there are, and how we could use them or how they can work in seed treatment. Seed doesn't really, well, seed looks like this, but seed doesn't really look like this. It looks more like this. And if you take a close look at seeds, there's a wide variety of bacteria and fungi and viruses and organisms present. These all range from beneficial to pathogens and everything in between. What you see on these plates is just the tip of the iceberg. There's a lot on seed that we cannot detect on agar plates like this. But if we take a really close look, we can find hundreds of thousands or even more microbes on these seeds. And it's important to know which ones we want to keep and which ones are going to cause us trouble. What's also important to know when you want to look at how to fight against these is if these microbes grow on the outside of these seeds or inside, because this will determine whether or not you're able to use a method and if that's going to be effective. So what do these seedborne pathogens do then? And why do we want to get rid of them? So a definition of a seedborne pathogen is any infectious agent carried on the seeds internally or externally that has the potential to cause disease in either seed or the developing plants. So that means that throughout the whole lifespan of a plant, these seedborne pathogens could cause challenges. Here are some examples. So there is fungi that can cause wilt or root rot, bacteria like Pseudomonas or Xanthomonas that can cause disease. But there's also viruses that cause different types of diseases, not only to plants, but also in the fruits. And it's a collective measure we need to take to deal with this. In current seed treatment, we can use something like hot water or steam to fight off pathogens. But the disadvantage is it kills every microbe on the seed, and it also has an impact on the quality of your seed. Another current practice is that we apply chemical plant protection products to the seed using different technologies ranging from film coatings to pellets. These plant protection products are applied months before the seeds are even in the field, and only by the time these seeds are in the field and the microbe starts developing, these chemicals are active. The benefit of that is that they also work then against the pathogens in the field, but it's a delayed attack, let's say. These different seed treatment technologies that we use, like film coat and encrustment, also give us the opportunity to apply all kinds of different compounds. Depending on the particle size, we can use different treatments. And these different technologies we can use to apply these biocontrol agents. So we'll be looking at a couple of different ones during the presentation, ranging from microbes to RNA to bacteriophages. We'll have a look at what their modes of actions are and how we then could use them in seed treatment. So there's a whole range of antimicrobial peptides available. As of January this year, there were over 3,000 natural antimicrobial peptides in the database available, produced by animals, plants, fungi, bacteria. And they work against a whole wide range of pathogens, including bacteria, fungi, and viruses. These peptides are built up out of different numbers of amino acids, ranging from about 10 to 60. So quite small when you think about having them applied onto a seed. The different modes of actions, like membrane disruption, inhibition of cell wall synthesis, inhibition of viral entry, means that they all work, or some of these modes of action work against living, or maybe living isn't the right word, active microbes, meaning that a cell needs to grow and multiply for these modes of actions to work. The nice thing about peptides is we can also use them against spores, which of course is a whole different attempt to kill microbes, because the spores are better protected. These, so the next biocontrol agent are enzymes. Also here, they are produced by all living organisms, and they play crucial roles in metabolic reactions. Here the same goes like peptides. They can degrade cell walls, they can degrade structures, and that means that they can kill or they can destroy cell walls of fungi. So that's one of the targets. They can also attack on bacteria. And also enzymes we can use to attack spores, which is an added benefit of these enzymes. Something that's newer in the world of biocontrol agents is RNAi. So that's double-stranded RNA that works through silencing of expression genes. The benefit of it is that it's not incorporated into the genome. The downside is it only works against fungi. The very nice thing is it goes very, very specific against a fungus. So it's not a broad spectrum solution. It attacks a specific fungi that you want. The downside is if you need to protect your seed from 10 different seedborne pathogens or 10 different soil pathogens, you need 10 different strains of the RNAi for it to work. The RNAi works against metabolically active fungi, so germinating spores or hyphae. It cannot attack spores as such when they are dormant. Over the years, fungi have developed resistance against plant protection products. So having something really, really specific like RNAi is a very good substitute. Then there's microbes we can use. There's many different microbes that all have a different mode of action, different microbes that they hit. So also here for a broad spectrum of attack, you would need a combination. And the mode of action here would be antimicrobial metabolites or volatiles. Competition, so if the beneficial microbes grow somewhere the pathogen cannot grow. Parasitism is also one of the modes of actions that microbes use. If your pathogen is inside the seed, for everything that I just already mentioned, all the methods, they need to be able to also get into the seed, which for some might be a bit difficult. One that actually quite easily could enter the seed is a bacteriophage, because that one actually relies on a host cell, in this case a bacterial cell, for replication. A bacteriophage attaches to bacterial cell, penetrates, replicates inside the cell, puts itself back together, and has then many more bacteriophages. The bacterial cell explodes and the bacteriophage spreads again. Unfortunately, it only works against bacteria, but we also have mycoviruses, and those can work against fungi. The benefit of having bacteriophages or mycoviruses is that they're self-limiting. This means that if you run out of pathogen, you automatically also run out of bacteriophages, because if there's no host cell available for the bacteriophage to replicate in, then the bacteriophage will stop existing. Phages are able to enter both active and inactive bacteria, but they only reproduce, the phages will only reproduce in metabolically active bacterial cells. All of these 5 different biocontrol agents that I touched upon very briefly all have their own modes of action, and if you want to use them, it's important to know what you're actually targeting. So what pathogen is on your seed? Is it in spores? Is it in vegetative cells? Is it inside the seed? Is it on the outside of the seed? And all of these questions together bring you to what you could or could not use. If we look at the bigger picture, there is different options to attack bacteria, to attack fungi, to attack viruses, ranging from broad spectrum to very, very specific. But for all of these goes that if we apply them in traditional seed treatment, so the same way we now apply chemical plant protection products, then they are inactive on the seed during storage, and they are supposed to work by the time the seeds are sown in the field. That means that for months or more than a year, these microbes, peptides, enzymes need to remain stable on the seed. That is because all the microbes that are on the seed are only active and therefore susceptible to these biocontrol agents by the time the seeds is sown and the microbes become active and start growing. For some, that is okay, but for some, that will be a challenge to make sure that the microbes survive, that your enzymes and your peptides don't degrade, and that your RNA and your phages also remain stable. So within seed treatment, from a technical point of view, there's quite some options, but from a availability point of view, the choices are still quite limited. So there's actually 3 microbes that are available in the Netherlands, which is where I'm based, and in plant protection product, the regulation is in such a way that you need to have a registration for a biocontrol product in the country that you apply it onto the seed. So in my case, that would be the Netherlands. There's 3 microbes that are registered as biocontrol agent, and that's it. So the potential is there. We just need to get these materials available. So I had a chat with my regulatory colleagues, and they came up with these statements saying that the disadvantage right now in registering these products is that the biocontrol agents are considered plant protection products. That is regardless whether they are from chemical or biological origin. That means that the use is very strictly regulated, both for placing them on the market and for their use, which is a good thing, but which also makes that it takes a long time to get these products registered. It's a long and expensive process, which also means that there's a preference to register the product as a biostimulant if that's possible, because that's an easier, faster route to market. The registrations that are being done are mostly done for large field crops, because large acres mean it's easier to get a return on investment. Currently, there is challenges for minor crops due to the limited number of allowed chemical plant protection products, and there's absolutely a number of crops that need solutions for biocontrol soon. So with this whole thing comes some considerations. So chemistry is robust, but its availability is limited and is becoming more and more restricted. And the microbes that are being targeted with chemistry are developing resistance. So either way, whether it's being restricted or the microbes developing resistance, we do need serious replacements.
Lo tocchiamo poi dopo, sì.
The effect of the biological control agents will depend on many environmental factors. So if we apply a microorganism onto a seed and we sow that seed in a field, and the first week there is a flooding, you will lose all your microbes and your effect of it. If the temperature isn't right, your microbe won't establish properly. There's many challenges that come with biocontrol agents in the field, many of which I think we can overcome, but we need to find strategies for that. And what is the long-term effect on the soil community if we put these biocontrol agents into the field? So that brings me to the conclusion that we have a lot of biocontrol agents that we potentially could use. We need to be aware of when they work and what state the microbes on the seed are to make the best choices. Shelf life of these biocontrol agents might be challenging. And it is unfortunately quite complex to get these products onto the market, which means that right now our options are limited, and we definitely need more moving forward. Which brings me to my last slide, which is questions, but I don't know if we're going to do questions right now or at the end. But yeah, well, thank you for listening, and yeah, just let me know if you have any questions.
Thank you, Carla, for the very nice talk. I do not see question now, but yes, there is a question. Thank you for the subject. I would like to ask a question. Apart from conventional bioagents such as trichoderma and bacillus, there are from many other bioagents that improve germination under conditional biotic stress.
I think there's quite a lot of microbes that could improve germination under stress conditions, but it will depend on what your crop is, what your stress condition is, and then you need to find the correct microbe to go with it. And even then you need to find the correct strain. So it's easy to say Bacillus and Trichoderma can do this, but the level of added value they can bring is very strain dependent. So the more you know about your problem, the easier in the end it will be to find your solution. But you need to screen different strains of different species to find your best answer to that.
Thank you, Carla. And another question from Soraya is, are there potential basic substances that could be used to treat seeds?
To have a biocontrol effect, or to have...
Yeah, the basic substances are an enlargement of the concept of biocontrol agent. Maybe we will be back on these in
Yeah, so the answer to this question also is depending on in which country you are, for which seed you need a solution. So what is allowed in the Netherlands can be different from Spain, can be different from Brazil, can be different from the US. So unfortunately, it's not like if we have a solution or if Lisbeth has a solution, then the whole world can use that. it's a very limited, yeah, it depends on very many factors.
Thank you, Carola. And for the audience, feel free to take the question, and maybe we will ask Carola during the general discussion. And hello to the people that join us in the behalf, and to the people that are following on Facebook page, and to the people that later we will see the video. Then let's move to Lisbeth van der Heijden that will talk. That are on the scene.
Am I? Yeah, I'm sharing my screen now. Well, good day, everyone. I'm very honored as well, like Carola also said, to be participating in this seminar. And I'm Lisbeth van der Heijden. I work at Biozade for 24 years in seed technology research. And we are very pleased to be able to present from a seed industry perspective on this subject. But first, allow me to introduce our vegetable seed company. I hope my slide is moving to the next slide.
Not yet.
Not yet. No,
oh,
it is.
There you go.
So it's very slow. I hope it will be a little faster in the next slides. But please allow me to introduce the history of Bio. Bio is a vegetable seed company, a family-owned company, and its origin already roots back to over 100 years, where there were two young guys starting to trade vegetable seeds in the Netherlands. It was not until 1978 where there was an official merge between these two family-owned companies in one family-owned company, Biozade. Bio today employs over 2,000 people worldwide. We have a very broad assortment. So we sell more than 50 different crops. We have about 1,200 varieties. The larger part of our assortment is also available for the organic market. And we have around the world, we have breeding, production, and sales. So we have breeding stations in the important continents to suit the needs of our customers. We produce seeds around the world at both hemispheres so that we have a full year supply of vegetable seeds for our customers. We have sales offices in 31 countries around the world, but the activities in sales reach to over 100 countries in the world. We are a Dutch-based company, so the head office is in Warmenhuizen in the Netherlands. Up till today, all the seeds that we produce are still shipped all the way to the Netherlands, and in the Netherlands they're cleaned, graded, tested, treated, enhanced, packed, and again distributed around the world again. And this is very important concerning the subject of today, and especially in relation to regulations, and that was already stressed by Carola just the same. Seed health testing starts with inspection of the seeds for pathogens, and yes, they can be carried on or with seeds, and when they're pathogens and they're considered seedborne, so not necessarily they are likely to transmit to the young seedling, we still face that some of the local national plant protection organizations regulate against the presence of certain of these pathogens on the seeds. So also for these seeds and for the seed transmitted diseases, we have to test our seeds to make sure that we are compliant with the regulations. Characteristics for detection method, and this is what we do with a lot of other seed companies together to make sure that we have agreed upon detection methods. But the characteristics are that they should be specific, so they should target what we're looking for. They should be very selective, So they should suppress what we're not looking for. Of course, they should be sufficiently sensitive that they actually predict that there is a risk for a problem. And they have to be reproducible and reliable. So when I do it on Monday morning or Thursday afternoon, or person A or B is doing the test, within a lab or between labs, we'd like to come to the same result. So those are very strong characteristics that have to be met. Preferably, we like them to be fast, easy, and cheap. And even though about 10 years ago, PCR tests were quite expensive, nowadays they're both fast and relatively cheap. So routinely, there's a lot of PCR testing in the lab. However, we also still apply all the other types of tests. So the bioassays, the grow out assays, seed incubation tests, pleat strakings, ELISA. Why do we do that? When testing seeds for pathogens, the outcomes really serve rather like warnings than actual risks. And the table here below lists the different types of tests that we have and the speed of the test, but also the information that is provided. So all of the tests will indicate the presence of the pathogen. However, not always an indication of it being alive or it being pathogenic is being provided by such an assay. We always consider the grow out test really as the golden standard. And a grow out test is not just sowing seeds and waiting for the disease to present itself in the seedling. Of course, also grow out tests are very specific. So you have to have the conditions conducive for the pathogen to actually be able to transmit into the young seedling. Having said this, to our opinion, this is the test that we have to use to check whether the application of a microbial inoculum to a seed is truly disinfecting the seed. What you have to be aware of is you apply quite a high amount of microorganisms of a biological control organism, and you would use a detection method that is rather sabotaged, so the sensitivity is lower because of the presence of the microbe. It doesn't really indicate disinfection, but you're sort of sabotaging the assay that you use. So we propose that from your list of infected seed lots, you select those seed lots that show positive results in your grow out assay. Then you treat your seeds and you see whether the seed can actually be fully disinfected using a microbial inoculum. Having said this, seed industry has a twofold responsibility for seed health. So we have to be compliant and we have to provide sufficiently healthy seeds to our customers. But we also have to respect the national phytosanitary regulations. And currently, seed health is based on the production of pathogen-free seeds by combining the use of fungicide applications in seed production, but also by applying fungicides in seed processing technologies. And in fact, if we want to become less dependent or even completely independent from chemical pesticides, we really have to have a shift in this paradigm of using fungicides to provide healthy seeds to our customers. So this paradigm really demands that we have a different view on microorganisms on the seed and not only consider them as pathogens, but also value the beneficial microbes on these seeds. Oh, going about 20 years back in time, this is the cocktail that we had up till about 20 years ago. In the Netherlands, we could supply the seeds with carbendazim, thyrum, iprodiol, and metalaxyl. We could apply it on all of the different seeds that we delivered, and we could also export it all over the world. So to be honest, about 20 years ago, we didn't test that many fungal pathogens on seeds because there was a cocktail of fungicides that took care of it. It is very reliable in disinfecting the seeds. When we look at Phoma, botrytis, Coletotrichum alternaria, so the main groups of pathogens that can be carried on seeds. And next to that, also this cocktail provided a perfect protection against damping of diseases like Fusarium, Rhizoctonia, and Pythium. However, and I think it's mainly in Europe, but probably progressing around the world, we've always considered seed as a carrier with added products, also providing protection. So I have not even discussed the insecticides, but insecticides have been banned in the Netherlands from seed coatings. And also we have experienced in the past 20 years the loss of all these individual fungicide components. So it already started in 2006 with carbendazim, and it followed 6 years later with Tyrum that we were no longer allowed to use for open field plantings. Iprodione was banned. Tyrum was banned completely by 2020, and also more recently, metalaxyl has been banned for Europe for the applicational seeds that are directly drilled in the field. And this means that currently we have fludeoxonil, but also this component is probably ending in the next 2 years, meaning that yes, we are in an urgent need for alternative treatments. And of course, microbial inocula are an interesting alternative. However, I think Carola also already indicated that there's not many alternatives available. So all the chemical fungicides have been banned. However, the replacement using fungal component of microbial inocula has not been taken the stage currently. Bio also has an organic market, so we were already looking into hot water treatments, but ever since we lost carbendazim in 2006, it really had a steep development. So we have hot water treatment installations, and we have improved this treatment. I think we do it every year, so it's under continuous improvement. We have also a steam vacuum treatment in place, where we have protocols for each crop pathogen combination very specifically. And of course, we are targeting for a window where the pathogen is completely reduced to zero while having maximum germination left. The point that I would like to stress, because again, to comply with many of the national plant protection organizations in the different countries, they prescribe that we have to treat with hot water at 50 degrees Celsius during 30 minutes. This window hardly ever is met. 30 minutes, 50 degrees Celsius, for sure, your pathogen will be eradicated, but about 50% of your germination is also lost. So we sort of try to get our hands together for very specific protocols that, yes, they target the pathogen to full extent, but we have to save our microorganisms on the seeds as well. Here's an illustration when looking at beetroot seeds that are planted. The picture shows when you plant beetroot seeds in Rhizoctonia infested soil. The graph next to it illustrates, like, if you have untreated seed that you plant on Rhizoctonia infected soil, you have an establishment of about 60%. When you apply metalaxyl on these beetroot seeds, you have an establishment of 90%. However, currently in the EU, we no longer have metalaxyl for beetroot seeds to plant in the field. If we treat our seeds now using physical measures compliant with the protocol that is requested for, so 30 minutes, 50 degrees Celsius, what you see is that these seeds have lost resilience compared to the untreated seeds. So yes, they're healthy. However, they're very vulnerable. For our export, that's not an issue as yet because we still have metalaxyl for export. So, however, in Europe, we really have a a gap for replacement of the resilience that we would lose if we wouldn't treat according to more specific protocols, but just a general protocol. To illustrate this with, well, what you see here is a carrot seed carrying a pathogen illustrated by red worms. And when you treat either with steam or with hot water, of course, what you aim for is that you have a healthy, clean seed. But yeah, in all fairness, there's a lot of microbes on the seed that are beneficial. And we also have a reduction in the beneficial ones. So what we focus on is, of course, to look into the seed microbiome as a whole, look what's there, and see how we can restore this microbiome. We also design protocols that are less harsh on the majority of the seed microbiome, and with that safe as much as we can. But alternatively, in light of the subject today, we could compensate the microbiome by using microbial biocontrol agents. So not bringing back what was there, but replacing it with a beneficial, resilient seed microbiome from another source. However, and this was also raised by Carola, when looking what we are allowed to use in the Netherlands for seed treatment, that is very limited. Here you see a drop down from a database that is kept by our trade organization, Plantum. This database holds all the chemical treatments and all the biological treatments that are available for seed treatment, vegetable seed treatment for the different countries. And here I've listed the Netherlands. And what you can see is that, yes, actually, we only have 3 microorganisms as active ingredients that can be applied on our seeds, and then it is very limited. So the Pseudomonas chlororhabis is only allowed to be used on carrot and pea. Pythium oleandrum was only allowed to be used on red beet, and that registration ran out during the course of this year. And we have streptomycetes, strain K61. It's a known strain. It has quite a wide registration, quite a number of vegetables. However, there is a precaution. The limitation is that they can only be applied to seeds of which the crop is grown under protected cover, so for greenhouses, meaning that in fact we have no answers to treat our seeds using microbial inocula at this stage. Just to show you an opposite result from the same database is when we select Brazil. You see that there's a very long list of microorganisms of different strains, combinations. And also very important, they have registrations to be applied to seeds of all vegetables, so no limitations whatsoever. We always look very jealous at the situation in Brazil. These are 2 examples, like the example that it showed from the Netherlands really applies for all the European countries. So in Europe, we have very limited amounts of what we can apply. In Brazil, they have a very wide amount of products that they can apply. I have looked into the other countries as well, and I think the other countries are sort of an intermediate. So these are the 2 extremes. So Europe, there's none. Brazil, there's a lot, and other countries are somewhere in between. What you also notice from this list of active ingredients is that it is a completely different composition than what we are allowed to use in the Netherlands. So there's no matching microorganisms, and I will get back to that later as well. Of course, because of all the fungicides being banned, all the chemical fungicides being banned in the Netherlands, we are continuously looking and working with producers of microbial inocula to see whether they can be a replacement, or at least whether they can have a function in a seed treatment. We do not start with testing on agar plates showing inhibition zones, because the complexity is really too low, and the prediction to the efficacy truly on the seed is yeah, it's almost zero. So we start with selecting the microbes that can be put on seeds, survive on seeds, and when we plant these seeds in infested soils under controlled conditions in our greenhouse, showing potential. The ones that show potential, we carry onwards to small plot field trials, and in the end, larger field trials. So in scope, we have certain products that we feel can be interesting. But yeah, registration is lengthy. Together with the efficacy testing, we always contact these microbial producers that there's some other considerations to be successful in seed treatment. And for one, it is scale. The volumes that a company like Bio uses is nothing compared to companies that treat soybean or corn or rice, potato. Still, we treat over 3,000 tons of seeds per year. We treat 50 crop, we treat 1,200 varieties. We do not have a campaign-wise treatment, so it is not working for us if there is a microbial inoculum batch delivered in March, treating seeds and planting in April. Now we treat every day, and we need a storability of about 2 years in our products before what do I say? We need very high quality products. We need microbial inocula with the same quality every day of the year, helping us to make sure that our seeds after treatment are really from a very high quality up till 2 years after treatment. And preferably, of course, we'd like these microbial inocula to be implemented in existing processes, while already knowing that is not always the case. But we need very robust, stable microorganisms, so they should survive the seed treatment processes that we have. Then they have to be storable, so when coated on seeds or treated on seeds, they should be stable, and not only at Bio under controlled conditions, but also during transport and at our customers, where often the temperatures and conditions are more ambient than conditioned. Last but not least, when looking around the world, I already said Bio is Dutch-based, but we're a global company. We deliver our seeds to all parts of the world. And you can already see that there's very different conditions around the world. We already see it in some of the chemical seed treatments that the efficacy may change slightly from the one country to the other country. However, when looking in microbial inocula, it is even more difficult and more challenging. And also in relation to, like if we are Dutch-based and we have to register for a seed treatment, we have the product has to be proven effective in the EU, and that has to be done in EU field conditions. And you can already see when you look at the EU that it is all sort of a green area. If we pass this lengthy process of getting a registration on seed under EU conditions, and we apply it to seeds in the Netherlands, and we export the seeds to California, you can already see that it is a different environment, different conditions, different substrates. And that probably also ties into the fact that we have different microorganisms registered in the Netherlands than there were registered in Brazil. So there's some challenges that have to be met when using microbial inocula, and the regulations to be compliant and be helpful. Therefore, we also look into using the seed microbiome itself. We've already noticed that seeds are fully covered in microbes and not only pathogens. So we're looking into our seed production areas. What are the microbes that are on the seeds? Are they delivered by the plant? Are they provided by external sources? How can we manage a healthy seed microbiome? How can we maybe even enhance the quality of the seed microbiome? Can we select for microbes that also have a very good dormant state so that they can survive our shelf life and transmit in the seedling after planting? Good management of a seed microbiome may also result in a reduced seed infection. But we are really looking into selection of microbes during seed production and of course as a seed treatment. So this is the picture that I showed earlier. I'll hear some final remarks of this presentation, and again stressing that apart from the limited availability of authorized microbial inocula for vegetable seeds, if seed disinfection is studied using microbial inocula, we have to make sure that we use the fit for purpose testing method. So are we truly disinfecting seeds, or are we sabotaging the sensitivity of the selected seed health testing assay? So we have to make sure that we come to real effects and not sabotaging effects. Second, when using physical measures based on a one fit serves all protocol, and again I stress the 30 minutes 50 degrees Celsius hot water treatment, this will not only eliminate the pathogen, but yes, it will also reduce the beneficial seed microbiome and hence result in a lower seedling vigor. Seedling vigor is not only a physiological aspect. The microbes play a very important role in seedling vigor and resilience. And last but not least, we always challenge the producers of these microbial inocula and the development for microbial inocula to please also consider the bottlenecks in application on seeds. They are challenging, but we are very needy of their solutions. And this was my last remark. Thank you for your attention.
Thanks to you, Lisbeth, for a very interesting presentation. I don't know, see question in the chat, but you highlighted very well. Yes, there is from Soraya. What do you think about using testing structure of beneficial microbes to treat seed? Do you think it will be an interesting way to increase survival during transport and storage?
I missed the first part of the question.
What do you think about using resting structures?
Resting structures, yeah. Well, yeah, that is one of the solutions. But of course, it should still be. I think what is meant is the resting structures of the microbial inocula. So selecting for the strongest, the strongest version of the microbial inoculum. So yes, please. And then at a very high potential. So we need quite a high CFU amount per gram of material to have a good inoculum on the seed.
Okay, and there is another question from Ruth Barnon. Do you see a chance of seed health method coming with more biocontrol becoming available, and what you will be? Strong question.
Of whether I see a future with many more products. Well, I see there's opportunity. But to be honest, I started working on this subject in 2000. And at that time, we already thought that the market would open up for organic products and biologicals. And up till today, it led to only 3 products available in the EU. what we've experienced with microbial producers is that even when they have tried in Europe, they are sort of scared away from Europe. The regulations are too tough. The registration process is too expensive, too lengthy, and low chance. So they sort of move to other parts of the world. So I think in other parts of the world, the chances are bigger that there's more products, and I'm still hopeful that we will change in the EU in the approach.
Thank you, Liz, but you highlighted very well this issue, and we are aware that in EU nowadays, to register a new compound that is PPP, even biocontrol agents, you need from 10 to 13 years, and a cost that can be also 300,000 euro, that 300 million euro actually, that it is a huge amount, and I don't know if this worth the cost or the time length. But let's move to a much better place by this side, that is Brazil, that is a paradise for biocontrol, and not only. And with Julia Manuela de Souza from Amphibio, in Brazil, it is possible to register biocontrol agent in 1 year. Am I right, Julia Emanuela?
Yeah, you're right. It's absolutely possible. We have some cases that we have some registers in 6 months. Depends on the information that they already have, and if the product safe. There are many points to consider, but we have 6 months, 1 year, but we still have 5 years, and it depends.
Feel free to share your presentation.
Okay, I'm gonna share my screen. Okay. Well, it's a pleasure to be here with such an important audience and such great speakers. I'm going to be talking in a regulatory point of view. I'm going to tell you how regulatory advances in bioinputs can be a path towards agricultural sustainability in Brazil. I'm Julia Manuela. I've been working in the bioinput sector for the last 8 years, and currently I'm the Institutional Relations Director at Amphibio. And Amphibio is the association of the biological industry in Brazil. And we have already 34 companies that are all focused in innovation and in sustainability. They are specialists in bioinputs for agriculture, and we all agree that the alliance between science and industrial development is the key for the success of the sector in Brazil. Those are our associated members. We have many profiles. We have startups, we have multinationals, and we have national companies that are members of Amphibio. But before we get started, I would like to tell you a story. I would like to know how the adoption of bioinput happened in Brazil. So in 2090, the 90s, the studies of soybeans and Bradyrhizobium, that's a bacteria that fixates nitrogen, their symbiotic relations started to be studied in Brazil. And the studies went so well that it became a commercial product. And the farmers started using, and they saw the results are so good that it scaled very much. And according to Embrapa in Brazil, 85% of the farmers, the soybean farmers, use Bradyrhizobium in their production. It is used in seed treatment and in furrow. It's worth mentioning that 95% of the farmers' costs with nitrogen, with chemical nitrogen, can be saved if they use biological products. In 1998 was sugarcane's turn to experiment the biological products. And the this experience was with Cotesia, which is an insect that controls a very important pest for sugarcane, which the sugarcane borer, and currently more than 3 million hectares of sugarcane uses this Cotesia in their production. But the most important moment for biologicals in Brazil was 2013, when we have this Helicoverpa armigera, which is a caterpillar, and it's damaged many crops in Brazil and around the whole country. And it shows some resistance for pesticides, and it was the chance of biologicals to show their worth, and they did. So the farmers started using for Helicoverpa, and they tried another categories, and it worked as well. So it started growing very fast in Brazil. The adoption started growing very fast. So according to Blink, in the harvest of 2022-2023, the potential area treated with bionematicides was 70%. With bioinsecticides was 20%, with biofungicide 10%, with inoculants such as Bradyrhizobium 51%, and other nutrient solubilizers about 2%. All these products can be used in furrow, in seed treatment, or in other way to use, since the company shows the studies that are carried out for efficiency. And the three first categories are registered in Brazil as a pesticide. And the last two ones are registered as fertilizers, which is very bad because we have different requirements for each kind of product. And even the registration process is different. For example, for pesticides, the company has to register their product, and the product has to be evaluated by Anvisa, which is the health agency in Brazil. It has to be evaluated by IBAMA, which is the Environmental Institute, and by the Ministry of Agriculture, which is gonna register and evaluate the efficacy. Once the product is registered, the company has to register their product in each stage where they want to sell it. On the other hand, if you register a fertilizer, you only go through the evaluation of the Ministry of Agriculture in Brazil. And the pesticide law is really new. It was approved last year and is still going through regulation. But for biological, there are 4 specific normative instructions. The first one is for biochemicals, second one for semiochemicals, the third one for insects, and the last one for microbials, which was updated last year, and it came with very good news. So from 2023 on, it's possible to register a GMO pest control product in Brazil. It's possible as well to register inactivated microbials and metabolites. So you can register enzymes and other kind of metabolites. The registration is made by target, not by crop, which means if you register the product for a specific target, you can use it in any crop in Brazil. And the last one is microbials that are biostimulators. So we have the way to register biostimulants, but it's not really clear what are the requirements yet. The fertilizers law is older. It's from the 1908, and the decree is from 2004. There is also specific normatives for biological products, which are for inoculants, biofertilizers, and for registration and methodologies. You can register a biological fertilizer, 2 types of biological fertilizers in Brazil. A biofertilizer, which can be a plant extract, an algae extract, amino acids, humic acids, or others. Or you can register an inoculant, which has to be a microbial. And as I told you before, we have these two ways, very different, with different requirements for registering. And it's the main challenge we have. But there are others. And one of them is the misuse, because as we all know, some products, some biological products have multiple functions. So if a product can be a pesticide control, a pest control, and it can be a fertilizer, a biostimulant at the same time. So a company registers it as a fertilizer, it only can be sold as a fertilizer. If the company says it controls pests, it's a problem. So the company has to register the same product in two different ways. Some technical incorrect definitions, because the laws are made for chemical products, and it's difficult to make sense when we talk about biological products and these laws that are made for chemicals, and the different requirements depending on the legislation. But I would like to stress a big problem that we're facing here in Brazil. It's our biggest challenge, I would say. It's the on-farm production. Producers, the farmers, they understood that they can do their own biological product in their properties. So they started doing this in open air with no quality control, with no kind of control. And it's been a really problem in Brazil. Some of them try to doing small fermenters. There are big farmers that do it in a better way, but still, there's no regulation, there's no supervision, there's no technical manager, there's no quality control, there's no traceability of the strains that they are multiplying on these fermenters. Even USDA wrote a report about it with their own concerns. So how to solve it in Brazil? Now, our idea as the industry is having a specific law for bioinputs, for all biological products, with correct requirements, where all these products can be treated in a similar way. And our objectives in this bill is to have technically correct definitions, is to have a proper quality control forecast for industry and for on-farm production, and to have appropriate requirements for registration. So what I would like you to say about the regulation in Brazil. The adoption of bioinputs in Brazil was motivated by the efficiency of these products and by the financial viability for farmers. It's different from other countries that the main idea is sustainability or the consumer appeal. In Brazil, the motivation was it's efficient and it's rentable for the farmers. Also, an adequate regulatory framework is essential for the bioinput sector to develop safely and quickly. That's why we are working really hard in a specific law for this product. And bioinputs still need better legal provisions in Brazil. A safe legal framework ensures the safe development of the sector. With that in mind, I would like to thank you for your attention. Those are my contacts. And if you have any questions, feel free to contact me. Thank you.
Thank you, Julia, for the excellent presentation. Basically, Brazil is a living lab for biocontrol for all over the world. So thanks for what you are doing. There is a question in the chat from Ines Macchiarola that tells, what about RNA interference? Do you think that sooner or later it will get in practice also in Brazil and maybe later all over the world?
Sorry, I didn't understand the beginning.
About the RNA interference, or the use of small RNA to target the plant pathogens and the seedborne pathogens. Do you think that one day we'll get it in practice in Brazil and maybe later in other parts of the world?
Well, I still don't understand the beginning of the question.
Okay, there is a chance to use a product based on RNA interference. So, do you think it can see the light for the control of seedborne pathogens?
Yeah, I think so. Yeah, in Brazil and the whole world, it's possible. We can still be hopeful, right?
Thank you, Julia. And there is another question from Soraya. I think on-farm production needs a few rules, but it is at the same time a great opportunity for biocontrol use. Do we have a comment?
I agree with you, Soraya. I totally agree. It was really good because the farmers, once they saw biological products are good, they are efficient, they started using more and more, but many times it's expensive for them. So they try to do themselves. It's good because it's expand the idea and the adoption. It's still a good way to have it. On the other hand, they need the rules, exactly what Soraya said. We need some rules. We need quality control because, you know, if you multiply biological products in a wrong way, you can contaminate it with very pathogen microorganisms, and it can be a big problem. But yeah, I agree, Soraya.
Thank you, Julia. Feel free to have a question to all the speakers in the chat and for the general discussion. But soon after, last presentation of Rob Gaffney that I will share, and that will have a point of view from the United States. Rob, the floor is yours.
Yes, Gianfranco, thank you so much. And ladies and gentlemen, it's certainly a pleasure to be with you. I hope you can hear me just fine. My name is Rob Gaffney. I work with BASF. I'm in the Agricultural Products Group. Obviously, the organization is based in Germany, but I sit here in the United States in the North Carolina regional office. And predominantly, we are a global enterprise. We're working and pretty active in most all countries when it comes to agriculture. We certainly have a seed company aspect of our business, as well as crop protection. And for years and years, and I'm not going to spend a lot of time on this slide, but just to advance, because the previous speakers certainly have addressed what are seedborne pathogens and what can we expect from it. But certainly from our point of view, as a provider of these kind of products that can help bring effective means to disinfect, whether it's seed-borne, soil-borne, things of that nature, any type of pest. We certainly have come from a place to where we relied on a lot of chemistry and synthetic chemistries. I think certainly in a lot of areas that still has a place and a role. But as we think about this subject and what you've heard to this point in time, I would like to take what seems to be an impossible ascent to the mountain to turn it to what's possible. So if you could advance the slide, please, Gianna. So again, there's many control management practices, but the primary process, obviously, what we play by is the seed certification through the various organizations. They have those rules and regulations and seed quarantines. And as Carola and Julia and Elizabeth have talked about, the seed industry in general has a lot of things on their plate here to make sure that they're bringing good, viable, quality seed that can be planted to growers around the world. Next slide, please. In terms of the chemical control, I won't get into a lot of it. You know, certainly there is chemical control methods out there. And the last bullet point, I think has been mentioned before, the increased regulatory challenges that many of us are facing around the globe. Not only are things being lost, but trying to register a synthetic chemistry is certainly time consuming and takes a lot of resources. But depending on where you're at in the globe, a lot of these things, the traditionals are still available, but certainly we as an organization recognize that in some cases, we're losing those tools in the toolbox, if you will. Next slide, please. So about this and today's topic is the biocontrol agents. The increased interest in the activity in this space is robust. And for the organization I work for, based here in the United States, we did have I did notice when Elizabeth talked about in Brazil, there were several of those biocontrol agents that were mentioned on that sheet, and I'll just utilize Bacillus firmus. In the United States, I was part of the organization that launched Bacillus firmus to be utilized on a lot of broadacre crops. In 2010, that was finally registered in the United States. Backing up to that, though, activity was started to be looked at on optimizing that to bring it to fruition and bring it to the marketplace. So 2010 was a regulatory milestone where it was registered, but all of the work started on that way back in the year of 2000. So it takes a long time to develop and optimize and bring that forward. But the bullet point there that I'd like to focus on, there's limited biocontrol agents currently available essentially around the globe for seed-borne pathogen protections. The Bacillus firmus in the US as well as Brazil does very well on soil-borne pathogens, but we're still trying to, what is it that we can identify? In our library, we have hundreds of thousands of candidates. It takes a long time to screen those. And what is the target specifically that we're trying to identify that they could be effective on? And just for example, here down below, there's a few of those that we've looked at and the various crops that are mentioned, but it takes time. Next slide, please. More recent interest in the microbial metabolites, and some of the depictions I have here is we are looking at a biological plant growth promoter, rhizobacteria. I think there was a question about helping with vigor and seedling growth. We're looking at this. We're not quite there yet, but the picture below would show when we're looking at some trichoderma type thing, when we put it together with a traditional fungicide use, we're seeing some nice responses from the check to the left on soybean to the check to the right in terms of more vigor, more growth. We're just trying to understand what will that really mean. And certainly it's not yet available for the marketplace. But these are the type of things we're looking at, taking a different approach and trying to see what specifically could be put together, what are the novel modes of action, what's the specificity, and certainly not only seed safety, but certainly we need to have the watch outs. It's what is it safe to the environment and to you and I as well as the humans. So next slide, please. Am I still there? I don't see the slides. Gianfranco, I don't see any slides, and maybe I've lost connection. Can you?
You're still connected.
Yeah, Gianfranco seems to have disappeared.
I apologize.
Not your fault.
Maybe he comes back on here shortly.
Hopefully, yeah, I think he's controlling the slides. So,
yeah.
There he is. He's back. You're muted, Gianfranco.
Yep. Here I am again.
Okay, Gianfranco, you threw me for a loop there for a minute. Next slide, please.
Okay.
What I'd like to spend a little bit of time here is on the U.S. regulatory oversight when it comes to biologicals. Next slide, please. So this slide here, I look at it as the 6 pillars in terms of the U.S. registration process. Probably some similarities around the globe, but for this point, I'd like to focus on what the process is here. It's top to right and bottom left to right as I go through that. So from product concept, just the things that we would look at on for traditional chemistry. And if we were to bring a new active chemistry to the marketplace, from the top left clear down to the bottom right, there's a lot of things that go on. It's time and it's resources. And I think Gianfranco, he had mentioned earlier on, the farther we move to the right on the top line, once product concept is done, and again, our scientists have, as a provider of these products, have probably reviewed those for several years prior to, but once the product concept is determined and we've identified the unmet need and our proof of concept can move forward, that's probably going to take a couple of years for sure. And once we move into the pre-submission area, that's an area where we start to talk and have conversations, particularly for industrial applied products, for these customers to start to take a look. We start sharing information about what it is and what they can do. And certainly not only from a federal registration point of view, we also have to be cognizant of what the various states' rules and regulations might be. So it takes a lot of time. And I would say in that kind of area there is probably another year or two at least. And then when we move over to the regulatory data generation, that's where a lot of the toxicology, the ecotox, all of that stuff has to be submitted and the regulatory body reviews. It's going to take time. And as we move down to the left bottom, for the US EPA submission, the nominal PREA timelines for a new AI is 21 to 23 months. New uses are 9 to 20 months. New formulations, if something was there, it's going to take at least 10 months. So then we move along into the middle of the bottom. We have a submission and registration. There could be additional data that's requested from the regulatory body. And if so, we would have to meet that requirement. But now we're all of a sudden into a phase of a product launch. And this is where we're able to move that into the marketplace where our customers to start utilizing. But as an aggregate timeline on my last bullet point, if it was truly a new active chemistry, from start to finish, it's probably 10 to 12 years to get that to the marketplace. And probably an average cost of those kind of submissions, including everything, at least from our view, it's probably going to be at least $300 million or more. Next slide, please. Pivoting to the microbial activity and what the US EPA data requirements would be. Not as many pillars, but almost. But again, it kind of lines up. Product chemistry, and this is where we would have the product concept. And we would go through essentially make sure that it all meets those requirements. When it comes to toxicology, we have to make sure that we meet those needs that the Office of Chemical Safety and Pollution Prevention would require. And if it's just acute, cost might not be so much. But the farther down on any of those bullet points that that submission could be, the higher tier studies conditionally are going to potentially cost more money. But moving over to ecotox or EFATE, we move down into residues. If something that we're submitting is going to require residues, at the end of the day, we look at these as we're going to register just like we would a synthetic chemistry. So from a biofungicide proof of concept or a biocontrol concept, from the concept to the market launch. Best case scenario in the United States, probably 7 years. Could be a little shorter depending on what the regulatory body might require. When you look at the resources that it would take for a biofungicide, certainly a whole lot different from what a synthetic chemistry would be. Anywhere from a range of $3 to $10 million would be for registration processes, from taking it from product concept to the market. Next slide, please. So looking ahead, and I first mentioned, it seems impossible, but we as an organization are looking at this because we believe it's critical. Sustainable food, feed, and fiber, accessible around the globe. Food security is critical for the geopolitical and social stability. And with increasing globalization and potential challenges of climate change, what those effects have on productivity systems, maintenance of regulator phytosanitary standards, which ROSE certainly, and as well as all of the other international bodies are looking at. We see a low incident levels of seedborne pathogens certainly can result in significant losses. But I think my primary drive here is we as an organization are investing into a new biohub in Limburgerhof, Germany, which we are hoping to bring foliar applied biologicals that can be used for growers around the globe. But more importantly, with that hub that we're building, it's about stabilizing these microbes that are going to be utilized. It's been mentioned before. A seed company applies products to the seed. Certainly it has to pass seed safety testings for a couple of, we've got to make sure it's safe on the seed and doesn't impact. It has to be stable and viable for at least a couple of years. I would go one step further. We would want to make sure that anything we apply to the seed biologically is stable and available to be active on that seed for the life of that seed. So those are internal challenges that we put upon our scientists to make sure we can do that. We certainly need to work closely with stakeholders. Stakeholders are all of us, to bring safe and effective solutions, curative and prophylactic, integrated disease management approaches, and a robust strategy for protection, disinfestation, or disinfection from seedborne pathogens. So at the end of the day, we need, along strict hygiene and seed certification rules, seed treatments are an important tool. The target's a whole lot less. It's 10% of what would be applied as broad acre applied over the top. And we need to make sure that they're adaptable in a variety of soil and seedborne pests and diseases of what could be approaching us. Improve resistance of genetics, I think, is key, whether that's using modern gene editing or silencing of the molecular techniques, RNAi, things of that nature, those kind of opportunities. Improve detection methods. Rapid, sensitive, inexpensive, easy to implement, harmonized. More importantly, how do we get internationally adopted threshold limits to be harmonized? And as we as an organization look at that, novel small molecule, molecular technologies, potentially vertically transmitted endophytes, it seems impossible, but I know our organization is taking up the challenge to try to turn this to what's possible not too distant in the future. So there are some products available today. A lot of areas are limited, but I think together it's a new day, a new start, and we certainly, I think the industry as well as around the globe, biological solutions are something I think that we all need to look at and embrace, make sure it's in a safe, effective, and sustainable manner. Gianfranco, I think that's the end of my contribution here, and I certainly appreciate the opportunity to present to the group here today.
Thank you, Rob. Excellent talk. Feel free to show up, you all, and let's have, so we are open for the general discussion, so you can place the comment into the chat or raise the hands and ask directly to the speaker. It was an earlier question to Carola. So about the option to target internal pathogens, there is experience about that from Collins?
So there is, universities are looking into how to fight endophytic pathogens, but they do a lot of research in plant, not necessarily in seed. That does give us a lot of information also what could work against these endophytes. Let's start with the challenge of what is on the outside, and if we can get some steps forward there, then go for the more challenging bits. Yeah, I think also after all the presentations that we've had, that one step at a time in this complex situation is the way forward.
If you don't mind me chiming in a little bit, since I'm the one who asked the question, you know, if we are looking at holistic seed health, in my opinion, I think it's important to make sure that we attend to those internalized pathogens. And also I have another thought-provoking question. When the ISTS sets thresholds, it's setting thresholds based on the external pathogens, right? Seedborne pathogens. That means we are not having a real picture of the real, you know, incidence of pathogens on seed. If we are only talking about the ones that are only external, do we have any assays, those that are non-destructive or destructive, that can actually, you know, shed more light on the holistic seed health, especially when you talk about, you know, international trade. And, you know, I'm asking because I've done these studies and I've found some of these pathogens that are internalized, and I've seen some other work from Cornell University where they reported some internalized pathogens. So really important that we think through things holistically. Thank you.
Thanks to you. I don't know if you want to answer, or if you have any answer, Carola, for this comment. Okay.
No, I think that's more a question to seed companies than it would be to the seed enhancement industry.
Thank you. Lisbeth, do you have a comment on this?
I don't think there's a clear one answer to the remarks made. I think there's we cannot say that we have answers to everything. We can say that for the pathogens that we know that are carried on seeds and in seeds, that we also have inside detection methods. However, it is all still sort of at a starting stage where we're looking at how we can study microbiomes as a whole. And these techniques are still developing, so I don't think there's a clear answer to that question yet.
Okay, thank you. Julia, do you have any comment on that?
No comments.
Rob, do you have any experience on the targeting of internal pathogens?
I think when it comes to internal, certainly there again, I think when we look at the synthetic chemistries that might be applied, particularly systemic, that probably adds, but in some cases those aren't available to be applied in certain areas of the world. But I think in general that, yeah, and then of course I think it was mentioned, seed companies would have to look at, okay, what's the opportunity, and you know, whether it's traded seed or things of that nature. But certainly it's a good question, and I'm not sure if I have the full answer for Collins there that he had asked, but.
Thank you, Rob. And for Carola, about RNAi, do you think there is a prediction of use for seedborne pathogen one day, soon or later?
RNAi, I think, especially in Europe, is early stages. So there is definitely research being done also by companies on how to deliver it, how to get it where it needs to be to actually be working. But that's only the first step. So if we're already facing these challenges to get a microorganism registered, then how are we going to get RNAi through the registration process? So yeah, I'm hopeful that we can get there because it's a very nice and specific method. So it won't kill the whole microbiome because that is something that we need to preserve for the seed. But I'm afraid it's going to take quite some years before we actually going to have RNA product on the market.
Thank you, Carola. Lisbeth, do you have any comment on this?
On what?
RNA interference. Options for seedborne pathogen management.
No, to be honest, I have no comment on that as yet. No.
Thank you, Rob. About your US perspective.
When it comes, I would just say this overarching from seed treatment application, I think there's still work to be done as to the applicability. More importantly, probably when it comes to that, seed industry is looking at what are they integrating into the trade.
Thank you. Any other comment or question by the audience?
I would comment on this. In Brazil, some universities and some companies are working in partnership to develop RNA products, and it's really working, doing well. We expect to have it in the market in the next few months.
Very good.
Is that then for foliar application or for seed?
Foliar.
Yeah.
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 Thank you. And if there are no any other comments, before Roel, do you want to ask anything?
Yeah. I have a question, and not specifically to anyone, but maybe somebody who feels to answer it can step in. So, do you think that the use of a bioagent can help in getting better seeds for the next generation, so that a bioagent somehow gets volatiles into the seeds and next generation seeds will already be performing better in quality against soil-borne diseases?
Carola.
Honestly, I don't know. It will probably depend on what biocontrol agent you're using, which specific disease that there is occurring at the moment, and all of that. So probably if it works, then one season you will have better results than the next season, or it would be nice if it worked that way, but I'm not sure that that's gonna happen.
Lisbeth?
It's an interesting approach. Of course, we already know that microorganisms in soil very much improve the offspring of a seed producing crop. So I wouldn't say that you would specifically target for a microorganism to increase a volatile or something in the seed, but yes, a healthy soil has a very beneficial effect on your offspring of your seed crop. So there must be something to gain.
Thank you, Lisbeth. Julia?
I absolutely agree with Elizabeth. She said what I would say.
Rob? to close the circle?
I just think so. Just to be clear, when we apply things to the seed, either for in seed or on seed or to go, that's to get the freshly planted seed crop up and out of the ground off to a robust start. As we move into later, as that crop is growing, it's going to be impacted by the various environmental conditions and probably whatever other type of crop protection products are put on to try to help minimize any potential, if it's a seed crop, any potential toxins that might come around because of environmental, that they minimize those so that when that seed is harvested for use on seed next year, that those things will reduce. But again, it's, yeah, I find it hard that a seed, well, maybe one day it will be possible, but for a seed treatment to probably bring that clear on to fruition for the next seed harvest, that's really asking a lot for that small amount of product put on. But
very good. Thank you so much to all the speakers and all the discussants. Thank to ISF, HISTA, and IPP for supporting this webinar. Thanks to Lucrezia D'Ortenzio that is behind the scene to manage this webinar. And before to go, I leave the floor to Professor Jose da Cruz Machado, that is organizing the next meetings next year dealing with seedborne pathogen. Jose, what you tell us? He's organizing a meeting in Brazil at the beginning of August next year. And he is planning a session on seedborne pathogens. Jose, are you with us? Okay, he will tell us anyway. So thanks you all again. And let's see next time. Enjoy and thanks for your contribution.